The lesson we're doing today is 1.5, subtracting rational numbers. This is the last new lesson that you're going to need to know before our quiz that we're having coming up on Monday. There's a saying that we've been going over multiple times. I want you to write this down with your red pen. This is going to be probably the most important thing, the most important concept that you need to know for your quiz. Sing the song to me. Same sign, add and keep, different sign, subtract. Take the sign of the larger number, then you'll be exact. If you know that, and if you know this other saying that we keep saying, what's the saying? It goes, every number has a sign, and that sign is directly in front of that number. If you remember those two things, you're going to do pretty well on our quiz on Monday. So let's go ahead and find some practice here. We're going to find the difference and write the fractions in simplest form. When you look at a problem like this, I want you to identify something right away. What do you think I want you to notice or identify? Yes, we want to find the double negatives. What do I do to a double negative? Turn it into a positive, and now I'm going to simply rewrite it underneath. I've got 1/3 plus 1/3. What's the answer? 2/3. Remember, whenever we have fractions, you want to always make sure that you have a common denominator. And then that makes it very simple. 1 plus 1 is 2. So 1/3 plus 1/3 is 2/3. Let's come on over here to this next problem. Whenever I have something like this, I want to get rid of my mixed number. So I'm going to turn it into an improper fraction. What would -3 1/3 be as an improper fraction?
10/3.
Okay, 10/3, but not just 10/3. What else do I have to bring down? Negative, all right? So if it was negative on top, then we have to make sure it's negative down there below. So just as a recap, remember you're going to be multiplying the 3 times the 3, and then you add the 1, and that's how they got the 10 right there. Now, there's the rest of this part that I've still got to drop down. So let's bring down -2/3. Do I have the same common denominator? I do, which is something that makes us very happy because that means I don't have to do any extra steps. So now I've got -10/3 minus 2/3. What would the answer be? What do you think?
I have a question. Wouldn't that be like a...
Remember, every number has a sign, and that sign is directly in front of that number. So this is a negative number, and this is a negative number. So when I think of that song, same sign, add and keep, those are the same signs. So I'm going to add the numbers. 10/3 plus 2/3. What is 10/3 plus 2/3? What's 10 plus 2? 12. Okay, so I get 12/3. And remember, we're going to add the numbers and keep the sign. What sign did I have here? Negative. So I'm going to go ahead and keep this as -12/3. Now here's the thing that it tells me. Write the fractions in simplest form. This is not simplest form. I can somehow reduce -12/3. What would that equal? Not 4/3. Okay, so this right here means that division, that means division, okay, if it's in a fraction bar. So that simply means 12 divided by 3. Guys, what is 12 divided by 3? 4. But if you remember, it was negative here, so guess what the answer is? The answer is going to be -4. And that is how you put it in simplest form because it can be reduced. All right, next up I've got problem C. As you can see, I'm finding the difference of fractions, but this doesn't look like a fraction. What should I put that over? A 1, okay, because 4 divided by 1 still equals itself. Now let's drop it down. 4 divided by 1. I'm going to also drop down my minus sign. Now, I don't want things to be a mixed number. I'm going to go ahead and turn everything into an improper fraction. Jonathan, what would that be as an improper fraction? Excellent. That is 11/2. Now I need a common denominator. Jonathan, what would the common denominator be? Very good. It's a 2. How do I get this 1 to turn into a 2? What do I have to multiply it by? Times 2. And if you remember, we've got to be fair. If I multiply it on the bottom by 2, I also have to multiply it on the top by 2. So Jonathan, if I'm taking this right here, what would 4/1 turn into as the equivalent fraction? 8/2 is correct. So we're going to drop down 8/2 below it. And then we have to remember we are subtracting 11/2. Every number has a sign, and that sign is directly in front of that number. Do I have the same sign or a different sign? Different sign. So what do I have to do? subtract and take. So let's go ahead and take 11 halves minus 8 halves. What do you get? 3 halves, 3 over 2. And take the sign of the larger number. Negative. Am I finished? No. What is wrong with this fraction? It's improper. So we've got to change that. What would that be if I change it to a mixed number? Okay, very good. Negative 1.5. Remember, if I had a negative right here, then I have to continue to keep that negative right there. For those who are wondering, how did you get that? You're simply taking 3 divided by 2, and when you work that out, you get 1 1/2. Once again, remember, make it a negative. All right, so today we said we're subtracting rational numbers. Remember, rational numbers are going to be both fractions and decimals. So now we're going to do a few examples. Same rules still apply, but now we're going to be using decimals. 2.4 minus 5.6. Same sign or different sign? Different sign. What do I have to do? Subtract, okay? What has the larger absolute value? 2.4 or negative 5.6? Negative 5.6 has the larger absolute value. So I'm going to go ahead and just take that 5.6, the absolute value of that, and subtract 2.4. What do you get? 3.2. Take the sign of the larger number. Which one was the larger number? Okay, the negative 5.6. So my answer is going to be negative 3.2. Let's go to problem E. Ansley, what's the first thing you notice about problem E? We do have a double negative, so we're going to go ahead and turn that into a positive, and let's rewrite it below. Now I've got something here, negative 8.8 and a positive 8.8. What should happen to those? They turn into a 0. Do you guys remember if I have negative 5 plus 5, what does that equal? 0. If I have negative 10 plus 10, what does that equal? If I have negative 30 plus 30, what does it equal? Remember the rule, a number and its opposite always equals 0. So here I had negative 8.8 plus positive 8.8. The answer is 0. Moving on to the next one, you can see there are 2 numbers after the decimal point. Keaton, how many numbers are after the decimal point on that one?
2.
Okay, right now it only has 1 number after the decimal point. All right, but I want to come up with a number so that I can compare these a little bit easier. What can I add to the end and it won't change it? A 0. Good job. So I'm going to go ahead and just put a 0 right there. Keaton, do we have the same sign or different sign? Different sign. Subtract and take. So we're going to take the larger absolute value, which is 0.50, or you could say 0.50, and subtract the smaller one, 0.45. Keaton, what do you get? Okay, it's not just 5. If you notice, you got to drop your decimal point down.
0.5.
Okay, you've got 0.05. Okay, because you've got to bring this down. You can also bring down this 0 if you want, but you do not need to if it's in the very front. However, you do have to leave that 0 in there, okay? Otherwise, it will change the value of our actual number. Now, take the sign of the larger number. Was the larger number up top positive or negative?
Negative.
It was negative, so what's my answer?
Negative 0.05.
Very good, okay? And once again, you can get rid of this 0 in the very front, and then we're left with just negative 0.05. Let's look at the final one. Taylor, help me with this one. 4.9 minus 1.6. Very good. It has different signs, so we're going to subtract it. Very good. Thank you for remembering to line up the decimal. We're doing 4.9 minus 1.6. What do you get? 3.3 is correct. Should you take the positive or take the negative? All right, we're going to go ahead and take the positive. Okay, now listen, this is a very basic problem that you've done, 4.9 minus 1.6. But now we can kind of understand how we're using the positive and negatives to help us to find the answer. So positive 3.3 is correct. All right, today I want to teach you something kind of fancy. It's called the commutative property of addition. Now, I want you to think about the word commute. We commute to school each day, all right? Sometimes you might say, I had a long commute. Other times you might say, I had a short commute. Do you guys think you might know what the word commute means? All right, so she mentioned kind of like a travel. That is correct. It is the distance, okay? I'm going on a commute, I'm going on a drive, I'm going to a place, okay? So to commute somewhere is to move somewhere or to go somewhere. The commutative property of addition says you can add numbers in any order and it will not change your answer. What this means is you can move the numbers around. Just like a car moves and drives you somewhere, you can move numbers around by using the commutative property of addition. So this addition keyword right here is saying when you're adding, it's okay to move the numbers around. So let's look down here at our cars. So here's what's happened to these numbers down here. Let's focus on the first car. It says 3 plus 4. What is 3 plus 4? 7. All right, that is 7. Let's go to the second car over here, and you can see it no longer says 3 plus 4. It says what? 4 plus 3. It changed the order of the numbers. Class, what's 4 plus 3?
7.
It is also 7. So notice we changed the numbers order, okay? Using the commutative property said we can change the order and it will not change your answer. So we're going to use that concept right now to help us with a few problems on the next page. Use the commutative property to solve the expression. So the first thing we're going to do, we've got negative 2 plus 5 plus 2. I want you to drop down that negative 2. Now what I want you to remember is every number has a sign and that sign is directly in front of that number, okay? So think about your name. You've got a first and a last name. Those two names go together, okay? You want to stick the name together. Just like with this is not just a 2, this is a positive 2. This is not just a 2, this is a negative 2. So kind of like a first and a last name, keep the sign with the number. Now, does anybody see in this problem the opposite of a negative 2? What is it? Positive 2. I'm going to use the commutative property, which told me I'm allowed to change the order of my numbers. I'm going to change this order and put the plus 2 next. Now there's one thing left up here I haven't used yet. What was that? Not just the 5, but the plus 5. Remember, every number has a sign, and that sign is directly in front of that number. We're going to keep that plus 5 with us. So let's go ahead, drop down the plus 5. Notice I have all the same numbers there. I've just changed the order of them. I want you to take your pencil and go ahead and underline negative 2 plus 2. That's a number and its opposite. What does a number and its opposite always equal? 0. It equals 0. So directly underneath it, I'm going to drop down a 0. And you can see all that's left right there is plus 5. So let's drop down plus 5. What is 0 plus 5? 5. Drop it down and box in your answer. Our answer did not change, but we were able to use the commutative property to help us move some numbers around. Let's go to problem B with the fraction. I'm going to start with the 1/5. Do you guys see the opposite of 1/5? What is it? Negative 1/5. Remember, every number has a sign, and that sign is directly in front of that number. So let's switch the order here. Negative 1/5. And what is still up there that I need to bring down? Plus 3/4. Let's bring it down. Thank you for saying plus, because that's a sign that goes with the number. Now let's go ahead and underline this here. What happens to 1/5 minus 1/5? It becomes a 0, and all that's left is plus 3/4. What's the answer? 3/4 is correct. There is something in problem C that I want you to notice and identify every time. What is it? A double negative. Thank you, Ansley. So we're going to go ahead and take that and turn it into a positive. Let's rewrite our problem and make it look neat and just bring down one regular sized plus sign. Now, you're allowed to use the commutative property anytime you're adding if you want to switch the numbers around. Sometimes you might say, I'm not interested in switching the numbers around. I want to just go ahead and keep them exactly as they are. That's fine. And you could work from left to right. Let's go ahead and do this. I'd love to see you do mental math in your head. 7.8 minus 3.3. What would that be? 4 what is 8 minus 3? 5. 4.5. Now some of you might say, I don't know how you guys just did that in your head. If you don't know how to do it in your head, you can always work it over here to the side. But if it's something you can do for mental math, I am totally fine for you to do it in your head. That's the same thing as 4.5. Now I'm just going to bring down the rest of my problem. Plus 1.2 plus 4.3. Now once again, I'm going to be working from left to right. So let's go ahead and underline this. Once again, mental math. 4.5 plus 1.2. What do you get?
5.7.
All right, 5.7. And then drop down this last part we have here, plus 4.3. Now once again, I can tell some of you are not into the mental math stuff. If you're not, you can just do it over here to the side. 1. What's the answer?
10.4.
All right, so I heard some people say 10.0. If you remember, as you're adding it, you can just get rid of that 0.0 at the end, and your plain old answer would just be 10. Main idea as far as commutative property goes, you're allowed to switch the order when you're adding numbers, and you're going to get the same answer no matter what. Next up, we talked about this yesterday, finding the distance between two numbers on a number line. Pull out your red pen for me, if you will, and go ahead and fill in those two blanks in your notes. We're going to find the absolute value of the distance of the numbers. So just remember, we talked about it yesterday, you cannot have a negative distance. I cannot run negative 5 miles. I just run 5 miles. I cannot measure an object and say, oh, that's negative 4 inches long. No, it would just be 4 inches long. So remember, distance is always going to be positive. If you remember, when doing distance, you're going to look at the actual number and try to see which actual number is bigger. Not which absolute value is bigger, just which number is bigger. So when I think about negative numbers, I like to think about money. What would you prefer to have, negative $3 or negative $7? I'd rather have negative 3. That means I only owe somebody $3. So negative 3 is the bigger of my numbers. When finding the distance, you take the biggest number, and then you have to subtract the smallest number. What was the smallest number? Negative 7 was the smallest number, so negative 7. What do you see in my problem? A double negative. Let's turn that into a positive, and I'm left with negative 3 plus 7. And what is negative 3 plus 7?
Positive 4.
It is going to be a positive 4. Problem B, you're trying to find the distance between the numbers 5 and negative 5. Go ahead and do it on your own. Okay, as I just walked around, I saw 2 answers across the room. Who can give me one answer that you got? What'd you get?
0.
A 0. Raise your hand if you got a 0. Okay, who's got a different answer? What'd you get? A 10. Did anyone else get a 10? Okay, so those were the 2 answers I saw, a 0 and a 10. Let's remind ourselves how to do a problem like this. When finding the distance, you take the biggest number and subtract the smallest number. What's the biggest number between 5 and negative 5?
5.
5, okay? Positive 5 is bigger. And now remember, you've got to subtract the smaller number. What is the smaller number? Negative 5. What do I do to those 2 negative signs? Turn it into a positive, and my answer is 10. Now remember, you're not just finding the answer, you are actually finding the distance. So let me help you by using the number line. It is asking if I were to have a 5 on a number line right here, and I had a negative 5 over here. Those of you who told me the answer was 0, you're saying there are 0 numbers in between a 5 and a negative 5. But that's not the case. You got to think. Instead, we are doing, if you hop backward, you would be hopping back 10 times. So the distance between those 2 numbers is 10. All right, so let's go to the next one. It says, what is the distance between negative 7.6 and negative 14.2? So basically, how many numbers come in between these 2 numbers? What's the bigger actual number? Is negative 7.6 bigger, or is negative 14.2 bigger? Think about money. Think about dollars. Which one is actually bigger? Negative 7.6. Why? Because that's closer to 0. Now I have to subtract the smaller number. The smaller number is negative 14.2. Ethan, what do I have in this problem right here? A double negative. Let's get rid of that, turn it into a positive, and when we drop it down, we are getting negative 7.6 plus 14.2. Same sign or different sign? different signs, subtract and take. So take the larger absolute value and subtract the smaller one. What do you get, guys? All right, Vivian, great job. 6.6. And take the sign of the larger number. Was the larger number a positive or a negative? Okay, it was a positive. So the answer is 6.6. All right, let's see what you guys came up with the think, pair, share. Do I have the same sign or different sign here? Same sign. Add the numbers, keep the sign. What did you guys get? All right, excellent job. When you added them up, it's 6.5, but you've got to make sure you keep that negative sign. Moving on to the next one. There's a lot going on here. The first thing you have to do with a problem like this is turn those double negatives into a positive. Next up, you can see you have different common denominators. So you've got to multiply both of them. And then you get 7/8 plus what? 6/8, which equals 13/8. And then you've got to turn that into a mixed number. What'd you guys get? 1 5/8 is correct. How many of you guys got that? All right, if you didn't, let me know what questions you might have, because you want to know and understand how to find that common denominator. And then remember, you never want to leave it as an improper fraction. You want to switch that up and make sure that you turn it into a mixed number. All right, the next one was kind of tricky for some people. All right, I've got 1/3. First thing you got to do is turn this into an improper fraction. What would that be as an improper fraction? 13/6. Okay, so remember, once again, we've talked about you want to make sure you have a common denominator. When you get that common denominator, you have instead now 2/6 minus 13/6. Do I have the same sign or a different sign? Those are different signs, guys, so I'm going to subtract 13 minus 2 equals 11/6. Take the sign of the larger number, but then remember, I cannot leave it like this because that's what? That's improper. I don't want it to be improper, so if I fix that, did anyone get what it would be? Okay, very good. And remember, it was a negative, so it's -1 5/6. All right, was there anyone who was able to figure out the distance between these two numbers? What did you guys get?
-6.1.
Okay, I heard a negative there. Remember, distance cannot be negative. So we're going to take that 10.6 and subtract 4.5. When you do that, you get 6.1. So the distance is just plain old 6.1.
Yeah.
Okay? Now listen, this is your homework assignment that has to do with this lesson for 1.5. You do not have to do it tonight. Okay? It's not due until Friday, but if you'd like to get it done and do it early, you may do it tonight.